స్టార్ట్ చేశారా? చేశారు అప్పుడే. సరే రండి, రండి. ఇంక క్లాస్ ఎక్కువ మళ్ళీ ఏమన్నా 6 వరకే బాగా 6 కి హోమ్ అని చెప్పిందంటే 6 క్లాస్ 6 వరకు వస్తాను పడతాను. ఇంక క్లాస్ ఎక్కువ మళ్ళీ ఏమన్నా 6 కి హోమ్ అని చెప్పిందంటే సార్ లైవ్ స్టార్ట్ చేస్తున్నాం కదా.
సార్ ఏమంటారు?
లైవ్ స్టార్ట్ చేస్తారా?
మేడం చరణ్ పడుకోను మేడం.
రీసౌండ్ వస్తుంది, రీసౌండ్ వస్తుంది సార్.
లైవ్ స్టార్ట్ అయినట్టు
లైవ్ స్టార్ట్ అయితే రీసౌండ్ వస్తుంది సార్. హలో
వస్తుంది కదా.
హలో
హలో,
మీ దగ్గర రీసౌండ్ వస్తుంది సార్.
అవును
మీరు
మీరే
యూట్యూబ్ బంద్ చేయండి.
అంటే తీసుకురామంటాను.
హలో
సార్
మీరు యూట్యూబ్ ది బంద్ చేయండి సార్. యూట్యూబ్ ఓపెన్ చేసి పెట్టారు, బంద్ చేయండి. సార్
హలో.
సార్ మీరు యూట్యూబ్ ఓపెన్ చేసి పెట్టండి సార్.
ఎవరు?
మీరే.
నేను చేయలేదు సార్.
ఇప్పుడు ఓకే, రీసౌండ్ వస్తుంది.
ఏకే వస్తుంది అంటే లైవ్ స్టార్ట్ చేసిన ఆల్రెడీ.
అదే మీరు మీ సిస్టమ్ యూట్యూబ్ ఓపెన్ చేసి రీసౌండ్ వస్తుంది.
ఎక్కడ ఓపెన్ ఉంది సార్? ఏం ఓపెన్ లేదు. క్లాస్ ఒకటి
ఇది షేర్ అయింది చూడండి.
అయింది కదా. ప్రెజెంటేషన్ మొదలు
అదే సార్
1 minute.
పెట్టిన కానీ నాకు అదే వస్తుంది. ఇద్దరు ఉంటాలకు వస్తలేదా సార్? రమేష్ సార్ హలో
సార్ చెప్పండి.
ఇద్దరం ఒకే దాంట్లో ఉంటారు. నాకు షేర్ అయింది కానీ కనబడుతుంది మళ్ళీ నా స్క్రీన్ మీద.
ఒకసారి క్లోజ్ చేయండి.
మీరే చేయండి.
నాకు సార్ ఫస్ట్ హోస్ట్ మీరే హోస్ట్ చేసుకున్నారు, రీక్లెయిమ్ హోస్ట్.
అదే సార్, నేను హోస్ట్లో ఉన్నా కానీ మీరు ఒకసారి నార్మల్గా మీ పేరుతో చేయండి కానీ.
ఏ సెల్ నుంచా?
సెల్ నుంచి చేయండి కానీ ఒకసారి ఇది క్లోజ్ చేయండి.
ఓకే, మళ్ళీ హోస్ట్ చేస్తున్నారు. ఓకే, ఇది లీవ్ చేయాలా?
సార్
సార్ ఇప్పుడు షేర్ చేయండి.
షేర్ చేసిన కాదు, మీరు నన్ను అన్ని ఓకే. ఇందాక నన్ను హోస్ట్ తీసేసారు మీరు.
ఓన్లీ హోస్ట్ చేసిన యువర్ ది హోస్ట్ నౌ.
నేను హోస్ట్లో ఉంటే నన్ను హోస్ట్ తీసేసి.
మళ్ళీ అట్లనే ఉందా?
సరే ఓకే.
ఇప్పుడు మీరే హోస్ట్ ఉన్నారు సార్.
సార్
వేరే ఉందా? అది ఒకటి రెండు రెండు జాయిన్ అయ్యా.
ఒకటి కెమిస్ట్రీ వాయిస్ వస్తుంది అని చెప్పిన కదా సార్.
1 minute.
ఇప్పుడు వచ్చిందా? ఇప్పుడు వచ్చింది కదా సార్.
స్లైడ్ అయితే వచ్చింది.
ఓకే
ఓకే
యూట్యూబ్లో వస్తుంది సార్. ఓకే, స్టార్ట్ చేయమంటారా? 10 మంది వచ్చింది. 10 మెంబర్స్ వచ్చింది సార్. సార్ రమేష్ సార్,
చెప్పండి.
స్టార్ట్ చేయమంటారా?
స్టార్ట్ చేయండి సార్.
ఓకే సార్. సరే సార్ మరి.
ఓకే నేను లీవ్ అవుతాం మరి. బాయ్. వీడియో ఆన్ చేసుకోవాలి.
ఆన్ చేసిన కానీ వస్తలేదు కదా.
మీ వీడియో ఇది వస్తుంది, మీ ఫోటో కనపడట్లేదు.
అదే వస్తుంది కానీ
యువర్ ది హోస్ట్.
వీడియో ఆన్లైనే ఉంది, నాకు డిస్ప్లేలో వస్తుంది కానీ. ఓకే
సిస్టమ్ ఓకే మరి. ఓకే సార్, మళ్ళీ ఇవ్వాలి.
సరే సార్.
రైట్, ఎండ్ చేసాను పని. వేరే క్లాస్ ఏం లేదు ఇక, మీరే కంప్లీట్ చేసేసాను.
ఓకే సార్.
ఓకే, అంతే అంత రైట్ మరి.
సరే సార్.
రైట్.
Dear students, good evening, all of you. Are you listening to me? Respond.
Good evening, sir.
Good evening. All of you listening to me? My voice is audible?
Yes, sir.
Okay. Myself, I am Dr. Rishal Ashok, Assistant Professor of Chemistry, Kakatiya Government College, Hanamkonda. Today we are going to discuss about the halogen compounds. It is one of the very important topic regarding. Are you getting? Is there any resound you are getting? Can anybody speak?
నో సార్ క్లారిటీగానే ఉంది వాయిస్.
క్లారిటీగా నాకు resound వస్తుంది. Okay. Now let us discuss about halogen compounds. What are the halogen compounds? Let us see. See, in the these halogen compounds, first time it was used in the Vietnam War for deforesting the jungles, so that the way going to be the clear to fight the against the enemies. And these halogens cannot be decomposed and broken down by microorganisms like bacteria. As a result of which, it is still intact in the soil of the jungles on to this day also. Do you know haloalkanes containing halogens like chlorine, bromine, and iodine are a threat to the atmospheric ozone? Can anybody tell me what is mean by depletion of ozone layer? Can anybody tell me what is the depletion of ozone layer? Nobody? What is meant by depletion of ozone layer? What is the main reason for the depletion of ozone layer? Can anybody? No? Don't have any idea?
Destroy the ozone molecule.
What is meant by depletion of ozone layer? That is nothing but depletion of ozone layer is nothing but having, that is.
Chlorine and bromine combined together.
Okay, can you tell me what is the main reason for the depletion of ozone layer? Main reason is freons. Can you tell me what is freons? Anybody?
Chlorofluorocarbons.
Where it is used? Freons are used. Where it is used? Freons. Okay, let me tell you. See, the main reason for the depletion of ozone layer is freons. Freons are nothing but chlorofluorocarbons. They are nothing but the chlorofluorocarbons. And chlorofluorocarbons are called freons. Mainly these freons are used as the what is called as refrigerants. Refrigerants is nothing but which is used for in the refrigerant. See, one of the very common example of the haloalkane compound is that lead to the ozone depletion is chlorofluorocarbon. And we might have come across haloalkanes and haloarenes several times in our day-to-day life, as well as industries for various applications. Let us know more about these organic compounds. How to name the haloalkanes? See, every compound, every organic compound having two types of names. One is called as common name, is also called as trivial name. And nomenclature common names require some set of rules. Another one is said to be the IUPAC. See, naming of ala cheyakandi, who is that doing? Naming of compounds by following certain set of rules is called nomenclature. We have to find three primary things for naming a compound in a IUPAC format. What are those? There are three words. Mainly in IUPAC nomenclature, we have three words. What are those? Find the parent chain. This gives that is the longest hydrocarbon in the given organic compound, and this gives the root word. And the second one is the find the functional group. It will give the suffix. You know, suffix stands for at the end of the word. And another one is find a substituents and position. It will give the prefix. what are the different substitutions are present in the given organic compound that makes the prefix. That means there are mainly 3 words. What are the 3 words? One is said to be the parent chain. This gives the root word. Another is the functional group that gives a suffix. Another one is said to be the prefix that shows the substitutions. Now let us see. The final functional group will form the suffix or prefix depending upon the priority series. Sometimes if it is more than 2 functional groups are in the same compound, 2 or more, and one will be the suffix and the remaining are the prefix. And which is suffix, which is prefix, that depends on the priority series. This is going to be the priority series. Suppose if you take SO3H and COOH both are there. In that cases, SO3H takes the suffix and COOH takes the prefix. Okay. See, in this way, if more than one functional group is present in this priority order, the first priority one goes to the suffix and the next priority will goes this one. Priority goes to the substitution. Suppose if you take the halogen is at the end of the this priority one. So that whenever all these functional groups are present, the halogen will take the prefix. But whenever only alone halogen is present, halogen itself take the suffix. Now see this one. The common name of haloalkane is alkyl halide. In general, we call it as alkyl halide. Methyl halide, that is methyl chloride, methyl bromide, ethyl bromide, propyl chloride, like that. That is called as the common name. And that common name is going to be the alkyl halide. IUPAC name of haloalkane written as in the following format. What are these? First is the numerical position of the halogen, alphabetically placed halo, and the root word that is going to be the ane. Ane means alkanes. See, let us see the one N-propyl chloride. It is a common name. And what is its IUPAC name? 1-chloropropane. Because here the chlorine is present on the first carbon. Therefore, it is going to be the 3 carbon. 3 carbon means prop is the root word. It is the longest chain. And chlorine is present on first carbon. That's why it is called as 1-chloropropane. See why it is called N-propyl. N stands for normal. Normal means there is no branch. And let us see the second compound. This is called as isopropyl chloride. Isopropyl stands for it is a branch. It is having, there is a CH3 on the second carbon. And it is having, whenever you get this type of compound, see, I will tell you here. See, whenever you have a branch like this, it is said to be the aniso. It is called as an iso. Whenever we have here an chlorine or bromine or anyone, it is called as this. Totally, this group is called as iso. That's why it is called as isopropyl chloride. And another point is here the chlorine is present at the second carbon. This is the first carbon. This is the second carbon. This is going to be the third carbon. That's why it is called as 2-chloropropane. Of course, these are all you know. And here it is called as N-butyl chloride or 1-chlorobutane. See, this one is called isobutyl chloride or 2-chlorobutane. This is what is a simple nomenclature. Whereas if you see this third one, it is going to be the tertiary. Tertiary stands for, suppose if it is the tertiary, this is going to be the tertiary. If you see, this is going to be the tertiary. Whenever you have this type of structure, you will have this is called as the tertiary carbon. Whatever it is having, suppose if it is having chlorine, tertiary butyl chloride. Suppose if it is having alcohol, OH group, it is called tertiary butyl alcohol. Like this, this structure is called as tertiary. Now let us see this one. The common name of haloarenes. It is common name is aryl halide. What is aryl halide? Like this. Benzyl chloride, chlorobenzene, like this. See, IUPAC name in this nomenclature system, the naming of the numerical prefixes depends on the basis of the position of the halogen on the aromatic ring. That means it may be, the halogens may be present at the different carbon. That's why that depends on the position of the carbon. If more than one halogen atom are present, the aromatic ring is numbered and the halogen group is named on the basis of the numerical position of the aromatic. Suppose you take this one. Numerical prefixes, you taken it as, it may be 1-2, that is position 1-2 position, 1-3 position, 1-4 position. Can anybody tell me what is 1,2 position? 1,2 position is nothing but we call it as the 1,2 position. We call it as the 1,2 position. We call it as the ortho position, isn't it? 1,3 position is called as meta position. 1,4 position is called as para. See, depending on the two halogens present on the benzene ring, it may be ortho, meta, or para di. Like this, if it is in the normal nomenclature, that is in IUPAC nomenclature, we call it as 1, 2, 1, 3, and 1, 4. Let us take the example. See, let us take this example. See, what is this is called? What is this is called? See, what is this is called? This is called at first carbon iodine, at second carbon methyl group is there. Therefore, 1 iodo, 2 methyl benzene. And now let us take this as example. Here, at the first position, chlorine is there. At fourth position, this is going to the fourth position. And at fourth position, this is the how many carbons? 1, 2, 3, 4. And at fourth position, it is called as 2-methyl propyl. At the second carbon, methyl is there. And total, it is a propyl. That it is a propyl group at second carbon methyl. That's why 4 2-methyl propyl benzene. Now let us see. The dihaloalkane having identical halogen atoms are termed as alkylidene or alkaline dihal. They can be divided into two types. What are those? One is called geminal dihalides. Another one is called as vicinal dihalides. What is geminal dihalides? Two halogens are present on the same carbon. If the two halogens are present on the same carbon, it is called geminal dihalide and vicinal dihalide. Vicinal stands for the two halogens are present on the adjacent in a compound. See, this is the example. Two halogens are present on the same carbon, so that it is called ethylidene chloride. It is an example for GEM. GEM stands for geminal dihalide. That means two halogens are present on the same carbon. And the IUPAC name of this compound is going to be the 1,1-dichloroethane. Suppose if you take the second example, here the two halogens are present on adjacent carbons. This is called ethylene dichloride. See the difference in the common name, ethylidene chloride and ethylene dichloride. It is called as WIC. WIC stands for adjacent carbon. WIC means vicinal dihalides. IUPAC name is at first carbon 1 halogen, at second carbon. That's why it is called as 1,2-dihaloethane. Because it is chlorine, then we call it as a dichloroethane. Now, let us see the classification of the haloalkanes. This is based on hybridization. What does this hybridization mean? See, suppose the chlorine, the halogen may be, see, the halogen, this is carbon atom and it is halogen is linked like this. See, this halogen, the carbon which is bonded to the halogen, it may be sp3 hybridized or it may be sp2 hybridized. Like this. Depending on the carbon that is bonded to the halogen, it is classified based on the sp3 hybridization or sp2 hybridization. If you see this example, sp3 hybridization. In this way, we call it as a primary alkyl halide, where the halogen is attached to 1 degree carbon. Halogen is attached to 1 degree carbon. When it is secondary halide, halogen is attached to secondary carbon. I think you have an idea regarding what is primary carbon, what is secondary carbon, what is tertiary carbon. And if you see the tertiary alkyl halides, the carbon is bonded, the halogen is attached to the 3 degree carbon. If it is allylic halide is nothing but the halogen is attached to the allylic carbon. I will explain you what is allylic carbon and what is benzylic carbon in the next slide. And whenever it is sp2 hybridized, the carbon which is bonded to the halogen, if it is sp2 hybridized, there are two types. One is vinyl halide, another is the aryl halide. Let us discuss one by one. See, that is, if you see, they can be classified on the basis of sp3 carbon halogen bond and sp2 carbon halogen. See, in the number of hydrogen atoms, on the base of the number of hydrogen atoms, they are discussed as mono, di, and poly. That means if it is 2 halogens are present, that is dihalogen compounds. If it is only 1 halogen is present in the compound, that is monohalogen compound. And if it is a poly means if it is 3 trihalogen compound, tetrahalogen compounds like that. It is named depending on the number of halogen atoms these compounds contained in their structure. That is, it is very simple example. Suppose if you take this example, here it is only 1 halogen, therefore it is called as monohaloalkane. Suppose if it is 2 halogens are, and this is called dihaloalkane. And in another way, it is also called, the 2 halogens are on the adjacent carbon, this is also called vicinal dimer. And if it is 3 halogens are present, this is called as trihaloalkane. Depending on the number of halogens, present in the given compound, they are mono, di, tri, tetra, like that halogen compound. By looking at the example, you can easily identify. See, this is another example. Suppose if you take only 1 halogen on the benzene ring, it is monohaloarene. If it is 2, it is called dihaloarene. If it is 3, it is called trihaloarene. And it is no problem. But whenever you have the 2 halogens, the position is called as 1,2 position. This is going to be the ortho dihaloarene, or we can say 1,2 dihaloarene. Suppose if you take this one, 1, 2, 3, that is going to be the 1, 2, 3 trihaloarenes, we can call it. Let us take here monohalogen compounds, again as a classification subclass on the basis of hybridization. Just now I told you. On the hybridization, see, there may be sp3 hybridized compounds or there may be sp2 hybridized compounds. In the case of sp3 carbon halogen bond, there are 3 types. Just now I told you, alkyl halides. See, in this class, the general formula is going to be the 1 halogen is removed from the alkane by halogen. Therefore, the formula is going to be CnH2n plus 1x. And they are further classified into the mainly 3 types on the base of the carbon atom, which carbon bearing the halogen atom bonded. That is primary, secondary, and tertiary. The classification based on the nature of the carbon atom to which the halogen atom is attached. Let us take these examples. This is going to be the primary carbon, primary alkyl halide. Why? Because this is going to be the carbon which is attached to the halogen, and this carbon is linked to only 1 carbon atom or 1 alkyl group. That's why it is a primary carbon, and this halogen compound is called primary alkyl halide. Suppose if you take the second example, here this carbon is bonded to the halogen, and this carbon simultaneously bonded to 2 alkyl groups or 2 carbons, so that it is a secondary carbon. The secondary carbon atom attached bonded with the halogen, therefore secondary alkyl halide. Similarly, it is a tertiary, that is 3. And you know that what is primary, what is secondary. See, suppose if a carbon is attached to only 1 carbon atom, and this is going to be the primary carbon. Similarly, a carbon atom is simultaneously bonded to the 2 carbon atoms, and it is going to be the secondary carbon. And if the carbon atom is attached to the simultaneously with 3 carbon atoms or 3 alkyl groups like this, and the center carbon atom, this carbon atom is said to be the tertiary. Similarly, that's why it is the primary. See here, this is going to be the primary, this is going to be the secondary, this is going to be the tertiary. Allylic halides. What is meant by allylic halides? In this case, the allylic halides is nothing but, see, in this case, the carbon is attached to, see, I'll tell you before this example, see, the carbon is attached to the halogen, but this carbon is linked to the 2 carbon atom. That is, the carbon atom is having olefinic bond like this. And this carbon, this carbon we call it as the allylic carbon. ఈ కార్బన్ మనం అల్లైలిక్ కార్బన్ అంటాం. ఏ కార్బన్ అయితే దాని అడ్జసెంట్ ఒక కార్బన్ డబుల్ బాండ్ ఉంటుందో దాన్ని అల్లైలిక్ కార్బన్ అంటాం. అలాంటి ఈ కార్బన్ కనుక మనకి హాలోజన్ అటాచ్ అయి ఉంటే అప్పుడు మనం ఏమంటామంటే దాన్ని allylic carbon antam. Let us take the carbon-carbon double bond structure is also known as allylic carbon. Thus, the name allylic halide. See this example. See, there will be a carbon-carbon double bond, and here this is going to be our carbon, which is bonded to the halogen, and this carbon is called allylic carbon, and this allylic carbon attached are bonded with the halogen. That's why it is called as the allylic halides. Now let us see vinylic halides. In vinylic halides, simply the halogen is directly attached like this. See here, the halogen like this. Now, see, this is going to be the double bonded carbon. Okay. Now here halogen is directly attached like this. This is called as vinylic carbon. This is called as vinyl group. And for this halogen is attached, therefore it is a vinyl halide. What is allyl halide? What is the, see the difference? Here the carbon-carbon double bond is there. This is vinyl group. And for this vinyl group, another carbon is there. And this carbon we call as the allylic carbon. And here this group is called as a vinyl group, vinyl halide, and this group is called as the allylic group. And for this, whenever a halogen is attached here, and that is going to be the allylic. This is allylic, and this is going to be the vinylic. Let us see examples for this one. See, what is this? Can anybody tell me? Can anybody tell me what is the first one? Is it allylic or vinylic? Is it,
Sir.
is it allylic? The circled one? First one.
Vinylic.
See, vinylic. Because this vinylic, that's why you don't get confused. That's why here I wrote. See here, this is going to be the carbon-carbon double bond. Okay, it is very similar to
Yes,
like
sir.
it is similar to like this. Therefore, whenever halogen is attached to the ethylenic carbon, you say in another way, that is called as vinyl. See, can you tell me the second one? This one. What is this? Vinylic or
Allylic,
allylic?
sir.
This is
Allylic.
allylic. Very good. This is going to be the allylic. See, the white is going to be the allylic. See, it is very similar to the first one. See here, this is going to be the carbon-carbon double bond, and this is going to be the allylic carbon. ఈ కార్బన్ కార్బన్ డబుల్ బాండ్ కి అడ్జసెంట్ కార్బన్ ని అల్లైలిక్ కార్బన్ అంటాం. దానికి హైడ్రోజన్ అటాచ్ అయి ఉంటే దాన్ని అల్లైలిక్ కార్బన్ అంటాం. అట్లా కాకుండా ఇలా డైరెక్ట్ గా డబుల్ బాండెడ్ కార్బన్ కి ఉంటే వినైలిక్ కార్బన్. ఓకే, నౌ లెట్ us see benzylic ions. This type of compounds is formed when halogen atom is attached to an sp3 hybridized carbon. See, in benzylic also the sp3 hybridized carbon. See, sp3 hybridized carbon atom should be present next to aromatic ring in order to form the benzyl halide. See, this is going to be the benzyl halides. I want to tell you one more thing here. Can anybody tell me what is the name of Can anybody tell me what is the name of this compound? You know, this is a benzene. Okay. Now I want to write another one is, suppose here it is CH3 is there. What is the name of this compound? If it is
Methyl benzene.
methyl benzene. Okay. This is going to be the methyl benzene. Now I want to, oh shit. Current పోయింది. Stay in that line. Slide is visible.
Yes, sir.
Slide visible ఉందా? కరెంట్ పోయి మళ్ళీ వచ్చింది. స్లైడ్ విజిబుల్ ఉందా అండి?
Yes, sir.
Okay. See, I want to remove this one. Just wait. మళ్ళీ రీస్టార్ట్ అవుతుంది. వెయిట్ చేయండి. ఉన్నారా? ఆర్ యు దేర్?
Yes, sir.
ఓకే, వచ్చిందా? మీకు స్లైడ్ వచ్చింది కదా?
Yes, sir.
Yes, sir.
ఆర్ యు గెటింగ్ స్లైడ్? ఓకే.
Yes, sir.
Okay. When benzene having the methyl group on the that is called as methyl benzene, or in another way we call it as the toluene, isn't it? Toluene is nothing but methyl benzene. Suppose whenever benzene having the like the CH2 group like this is called as benzylic group. ఈ గ్రూప్ ఏమంటామంటే బెంజైలిక్ గ్రూప్ అంటామండి. రిమెంబర్, బెంజీన్ హ్యావింగ్ CH2 లైక్ దిస్. టాల్విన్లో ఒక హైడ్రోజన్ తీసేస్తే వచ్చే ఆల్కైల్ హాల్ లాగా వచ్చేది ఈ గ్రూప్ బెంజైలిక్ గ్రూప్ అంట. సపోజ్ ఇఫ్ ఐ రైట్ హియర్ Cl, కెన్ యూ టెల్ మీ వాట్ మే బి ద నేమ్ ఆఫ్ దిస్ కాంపౌండ్?
Benzyl chloride.
Benzyl chloride, very good. See, suppose if I write OH here, like this. If I write OH, can you tell me what may be the name? Can you tell me what may be the name? చెప్పండి.
Benzyl
ఇందాక
chloride.
OH ఉంటే ఏమంటాం? ఏం కాంపౌండ్స్ కి OH ఉంటుంది? ఏ కాంపౌండ్స్ కి OH గ్రూప్ ఉంటుంది? ఏమండి? Which compounds have the OH?
Alcohol.
Alcohol. ఇప్పుడు చెప్పండి, పేరు ఏమైంటుంది దాన్ని?
Benzols.
Benzyl alcohol.
Benzyl alcohol.
Good. It is benzyl alcohol. Okay. Benzyl chloride అన్నట్టు benzyl alcohol. Okay na? Now, see, I want to tell you one more important thing is, see, whenever a group is like this, I am writing here. This, benzene, isn't it? Suppose it is having C double bond O CH3. Can anybody tell me what may be the name of this compound?
Benzoic acid.
Can anybody tell what is the name of this compound? Not benzoic acid. Anybody?
Benzaldehyde, sir.
Benzaldehyde కూడా కాదు. వెరీ గుడ్. acetophenone. ఎవరు? S2. everyone S. ఎవరు? acetophenone చెప్పింది ఎవరండి? మీ పేరు చెప్పండి. టైప్ చేస్తారు కదా acetophenone అని. Is this acetophenone? Okay. Are you followed?
Yes, sir.
Okay. Now I want to change some. Okay, I want to change something here. This is some important things. ఎందుకంటే పిల్లలు చాలా కన్ఫ్యూజ్ అవుతుంటారు, అందుకని ఇక్కడ స్ట్రెస్ చేస్తున్నాను. సపోజ్ వెన్ ఎవర్ దిస్ ఇస్ ద గ్రూప్, ఇందాక మనము ఈ గ్రూప్ని ఇందాక మనం ఈ గ్రూప్ చూసారా? ఈ గ్రూప్ని ఇందాక ఏమనుకున్నాం మనము? ఈ గ్రూప్ని ఏమన్నాము? బెంజైల్ గ్రూప్ అన్నాం. ఈ బెంజైల్ గ్రూప్ దగ్గర క్లోరిన్ ఉంటే బెంజైల్ క్లోరైడ్, లేదా OH ఉంటే బెంజైల్ ఆల్కహాల్, ఇంకా బ్రోమిన్ ఉంటే బెంజైల్ బ్రోమైడ్, అలా చెప్పాలి. మరి ఇలా గ్రూప్ ఉందనుకోండి, సిమిలర్గా ఇలా గ్రూప్ ఉందనుకోండి, దీన్ని ఏమని చదవాలంటే ఇట్ ఈస్ కాల్డ్ యాజ్ BENZOYL. చదవండి, ఏంటిది ఇది?
Benzoyl.
బెంజాయిల్ అంట. దీనికి తేడా చెప్పడం కోసం నేను చెప్తున్నాను. ఏంటిదంటే ఏం తేడా కనిపించింది మీకు? ఇప్పుడు ఇక్కడ బెంజాయిల్ అని రాశాను, ఇక్కడేమో బెంజైల్ అని రాశాను. దీని పేరు ఏమని చెప్పాను? ఇది బెంజైల్. NZYL. వాట్ ఈస్ ద డిఫరెన్స్? ఈ రెండింటికి ఏం డిఫరెన్స్ కనపడిందండి? బెంజాయిల్, బెంజైల్. ఇందులోకి ఒక ఓ డిఫరెన్స్ ఉందండి. అవి ఐడెంటిఫైడ్. బెంజాయిల్లో ఓ డిఫరెన్స్ ఉంది. బెంజాయిల్లో ఓ ఉంది కాబట్టి మీరు ఏం గుర్తుపెట్టుకోవాలంటే బెంజిన్ మీద కూడా ఓ ఉన్నట్టే. సి దిస్ వన్, ఐ విల్ టెల్ యూ. సి, బెంజిన్ మీద ఇప్పుడు మన నేమ్ లో ఓ వచ్చిందంటే బెంజిన్ మీద కూడా సి డబల్ బాండ్. ఓన్లీ బెంజైల్ అని వచ్చింది అనుకోండి, అందులో ఓ లేదు, డైరెక్ట్ CH2 ఉన్నట్టు గుర్తుపెట్టు. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ హియర్ ఇఫ్ ఐ రైట్ సిమిలర్లీ, ఇక్కడ OH రాశాను కదా, OH కుదరదు కానీ ఇక్కడ ఏం రాశాను? Cl రాశాను. ఇక్కడ కూడా Cl ఉంటే ఏమని చదువుతాము, ఇక్కడ Cl ఉంటే ఏమని చదువుతాం. ఇక్కడ Cl ఉంటే బెంజైల్ క్లోరైడ్ అని చదువుతాం హియర్ ఫస్ట్ కేసులో. ఈ రైట్ సైడ్ ఉన్న దాంట్లో ఇలా ఉన్నట్లయితే దీన్ని ఏమని చదవాలి మనము? బెంజాయిల్ క్లోరైడ్ అని చదవాలండి. దీన్ని ఏమని చదవాలి మనము? బెంజాయిల్ క్లోరైడ్. దీన్ని ఏం చదవాలి? బెంజైల్ క్లోరైడ్. See a simple difference. Okay. Now the compound having the sp2 carbon. See రెండు చూడండి. ఈ లాస్ట్ లో ఉన్న రెండు ఎగ్జాంపుల్ చూడండి. ఏమిటి దీనికి ఎగ్జాంపుల్ అండి? ఇవి వినైలిక, అల్లైలిక?
Vinylic, sir.
ఫస్ట్ వన్ ఏంటిది? ఫస్ట్ది వినైలిక్. సెకండ్ది ఏంటిది?
Vinylic, sir.
వెరీ గుడ్. ఈ రెండు కూడా వినైలిక్ హాలైడ్స్. Now let us see aryl halides. This class of compounds in the chapter, this is called as simply one halogen if it is present on the benzene ring, that is called as aryl halide. Just 1 minute. Okay. Now do you have the pen and paper with you?
Yes, sir.
Okay. Now write down the structure of this perfluorobenzene. All of you write down the structure of perfluorobenzene. Over. If it is over, I will show the answer. రాసారా ఆన్సర్ మీరు?
Yes, sir.
You wrote the answer?
Yes, sir.
One minute. Okay, okay. Can you write the name of the structure?
One bromo 2, 3 dichlorobutane, sir.
Very good. Let us see. 1 bromo, 2,3 dichlorobutane. Very good. Now, can you write the name of this compound? By looking at the compound, you can tell me the name. This is nothing but 3 carbons, therefore pro.
One ionopropane, sir. One ionopropane.
One
Propane.
iodo. Can you tell me what is the name of this compound?
Cyclofluorine.
Cyclofluorine. How do you say cyclofluorine? How do you say cyclofluorine? Is it cyclofluorine? What is this compound? Can anybody? What is the name of this one? Can you tell me what is the name of this compound?
Pyrrole, sir.
This is triangle laga రాసేది దీని పేరేంటి? 1, 2, 3 carbon are linked with each other. THF కాదు బాబు, టెట్రాహైడ్రోఫ్యూరన్ కాదు.
Propane.
ఉత్త ప్రోపేన్ ఎట్లయితుంది?
Cyclopropane.
Cyclopropane.
ఇప్పుడు దీని పేరేంటి? తీసేయండి.
Cyclobutane.
సైక్లోబ్యూటేన్. మరి ఇదేంటి?
Chlorocyclobutane.
Cyclopentane.
Cyclopentane.
చెప్పండి. వాట్ ఇస్ ద నేమ్ ఆఫ్ దిస్ అవర్ క్వశ్చన్? సైక్లోపెంటేన్ కదా ఇది. ఫ్లోరిన్ ఉంది సైక్లోపెంటేన్ మీద. అప్పుడు నేమ్ ఏమవుతుంది? ఏమైందండి?
Cyclofluoropentane, sir.
సైక్లోఫ్లోరోపెంటేన్ మధ్యలో ఫ్లోరిన్ వస్తుందా?
Fluorocyclopentane.
Fluorocyclopentane. Okay. Can you tell me the name of
Pentane.
this compound? What is the name of this compound?
Iodobutane, sir.
Iodobutane అవుతుందా? మంచిగా చూడండి.
Two iodo, two methyl
propane.
Very good. Who is that? You. మీరు ఇట్లా సింబల్స్ పెట్టుకుంటే ఎట్లా మీ పేరు కరెక్ట్ రాయాలి దాన్ని. యుఎస్ ఇవన్నీ చెప్తే ఎట్లనా? యుఎస్వి ఇట్లా సింబల్స్ పెట్టుకుంటాను, మీ పేరు పెట్టుకోలేదా? ఓకే, యు ఆర్ రైట్. See this compound 2-iodo 2-methyl propane. It is the name. Can you tell me what is the name of this compound? మీరు పేరు పెట్టుకోండి, ఇట్లా ఎస్లు యూలు పెట్టకండి. ఒకరు ఎస్ ఒకరు యూ పెట్టుకున్నారు పేరు.
2,4-butane, sir.
2,4-diboropentane.
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 2,4-dibropentane, right. What is the name of this compound?
మిథైల్ క్లోరోబెంజిన్ సార్.
మిథైల్ క్లోరోబెంజిన్ అంటే సరిపోతుందా? మిథైల్ ఎక్కడుంది, క్లోరిన్ ఎక్కడుంది చెప్పాల్సిన అవసరం లేదా?
1-chloro-4-methyl-benzene.
1-chloro-4-methyl-benzene or
4-chloro.
4-chloro. బికాస్ మిథైల్ బెంజీన్ ఏమన్నా మనము టాల్విన్ అన్నాం కాబట్టి టాల్విన్ లో పారా పొజిషన్ లో ఫ్లోరిన్ ఉంది కాబట్టి 4-chloro టాల్విన్. ఓకే, నో నాట్ ఎట్ ఎండ్. నేను మళ్ళీ ఇంకోటి షేర్ చేస్తాను, వెయిట్ చేయండి, ఇంకో స్లైడ్ షేర్ చేస్తాను. వచ్చిందా మీకు స్లైడ్? వచ్చిందమ్మా?
Yes, sir.
సార్.
ప్రజెంటేషన్ మోడ్ వచ్చిందా? స్లైడ్ మూవ్ అవుతుందా? మూవ్ అన్నట్టుంది కదా.
No, sir.
Not yet, sir.
Just a minute. Have you got?
Yes, sir.
Presentation. It is not getting presentation. ఇందాక వచ్చినట్టు presentation. ఓన్లీ స్లైడ్ చేంజ్ కావట్లేదమ్మా. చిన్నగానే వస్తుంది కదా మీకు స్లైడ్. మీకేం స్లైడ్ చేంజ్ కావట్లేదు కదా?
ఎస్ సార్. చేంజ్ అవ్వట్లేదు సార్.
నా దగ్గర చేంజ్ అవుతుంది, మీ దగ్గర అవుతుంది.
ఇప్పుడు అవుతుంది సార్.
ఓకే, ఇలా చెప్పండి మరి. ఇక్కడ క్లియర్ ఉంటుంది, ఇట్లా చెప్తే మీకు ఇలా చెప్తే క్లియర్ ఉంటుందా మీకు?
ఓకే సార్, మేము జూమ్ అవుట్ చేసుకుంటాం.
జూమ్ చేసుకోండి, ఎందుకంటే ప్రజెంటేషన్ మోడ్లో స్లైడ్ మూవ్ కావట్లేదు. ప్రజెంటేషన్ మోడ్ అయితే నాకు కావట్లేదు. Okay, in this session, we will going to discuss about the two things about the halogen. The chemical reactivity of halogen compounds as well as the formation of Grignard reagent. What is this chemical reactivity of halogen compounds? Let us see. The alkyl halides undergo two types of reactions mainly. What are those? One is nucleophilic substitution reaction. Another one is elimination reaction. What is meant by nucleophilic substitution reaction? What is meant by substitution reaction? Anybody?
The replacement of nucleophile with other nucleophile is called nucleophile substitution reaction.
And I'm asking you, what is substitution reaction? What do you understand by substitution?
Displacement.
Displacement. That is, one group is substituted by another. Like our Coco game. Coco game తెలుసు కదా మనకి. Coco game లో ఒక ప్లేయర్ ఇంకొక ప్లేయర్ ఎట్లయితే కో ఇస్తారో, సేమ్ ఇక్కడ కూడా సబ్స్టిట్యూషన్ రియాక్షన్ లో one group or one atom is going to be substituted by another group or another. Okay. Now, what is elimination reaction? What is elimination? Removal. Elimination is nothing but some removal. That means a small groups, small atoms or small groups like H2O or the alcohols or H2 like that, alkyl halides, that is hydrogen halides like that, they are removed from the molecule. Such reactions are called elimination. In nucleophilic substitution reaction, there is no change in the bonds. What I mean to say, that is nucleophilic substitution reaction mainly undergone by the, what I mean to say, alkyl halides. That is, what do you understand by alkyl halides? What I mean to say, haloalkanes. That is only the halogen attached to the halogen, alkane groups. In the case of the elimination, the alkanes, that is haloalkanes, are converted into the olefinic bonds. Let us, I will discuss with an example. See, in the case of the nucleophilic substitution reaction, the carbon halogen bond is halogen compound is polar in nature because of the high electronegativity of halogen. If you see the carbon and halogen, if you see the carbon and halogen is more electronegative. Therefore, the bond between the carbon and halogen is polar in nature. Therefore, the carbon will get the partial positive charge and the halogen will get the partial negative. And this can be represented with this, the carbon halogen partially positive charge, hence shows acidic property, and electron deficient atom or electrophilic character. So, it is readily attacked by the nucleophiles. Halogen compounds readily undergo nucleophilic displacement reaction. See here, Rx, it is an alkyl halide, that is nucleophile. The X is replaced or substituted by the nucleophile. This is a one common reaction. If you see here, elimination reaction. What is elimination? In the case of the haloalkanes, if it contain any beta hydrogen, I think you know what is alpha beta. The halogen or functional group attached carbon is called alpha carbon. Then the next carbon is beta, and the next carbon is gamma, omega, and so on. See, whenever it is having the hydrogen at the beta position, it is highly acidic. This hydrogen is highly acidic, and this will be replaced or it is removed by a strong base. Whenever we use a strong base, and this hydrogen is acidic, therefore it is removed. For example, dehydrobromination of ethyl bromide in the presence of alcoholic KOH. What happened? The OH takes the hydrogen because it is a strong base. The hydrogen is taken and the bond is shifted to between the carbon and carbon. In the same time, bromine is removed. Therefore, you will get two single bonds are removed. This single bond and this single bond is removed, and there is a formation of the double bond in the elimination reaction. See, another reaction we can say reduction. Reduction is nothing but alcohol halides when reduced with the nascent hydrogen. Can you tell me what you understand by the nascent hydrogen? Can anybody tell me what you understand by the nascent hydrogen? Sometimes we also call nascent oxygen.
Single hydrogen.
మళ్ళీ చెప్పండి. Nascent అనే టర్మ్ యూజ్ చేస్తూ ఉంటాం. Nascent. What do you understand by the nascent? Nascent hydrogen, nascent oxygen. చెప్తారా ఎవరైనా? Nobody? The nascent stands for just born. Just born. చూడండి, ఇక్కడ జస్ట్ బార్న్ హైడ్రోజన్ కానీ ఆక్సిజన్ కానీ మనం ఎప్పుడైనా బ్రాకెట్ లో ఉంచుతామండి, గుర్తుపెట్టుకోండి. ఇలా బ్రాకెట్ లో జస్ట్ బార్న్ అన్నమాట. ఈ నేసెంట్ హైడ్రోజన్ కానీ ఆక్సిజన్ కానీ దే ఆర్ ప్రొడ్యూస్డ్ ఇన్ ద రియాక్షన్ అండ్ కన్జ్యూమ్డ్ ఇన్ ద రియాక్షన్. ఇట్ ఈస్ నాట్ పాసిబుల్ టు ఐసోలేట్ దెమ్. ఈ నేసెంట్ హైడ్రోజన్ కానీ ఆక్సిజన్ కానీ అంటే దాని అర్థం ఏంటంటే రియాక్షన్లనే జనరేట్ అవుతాయి, రియాక్షన్లనే కన్జ్యూమ్ అయిపోతాయి. మళ్ళీ వాటిని మనం బయటకి ఐసోలేట్ చేసి స్టోర్ చేయడం కుదరదు. ఓకే, సి the nascent hydrogen, whenever nascent hydrogen is applied to the alkyl halides, they can be reduced and they converted into the alkanes. There are 5 reducing reagents, mainly hydrogen over a metal catalyst. Metal means nickel or platinum or like that. Another one is said to be the zinc and hydrochloric acid. Another one is hydrogen iodide and phosphorus. One more is LAH. LAH stands for lithium aluminum hydride. Another one stands for magnesium and H2O. This H2O. See, nascent hydrogen means just born. That means it is generated in the reaction and it is used. For this, in the reduction of the alkyl halides, we use mainly hydrogen over metal catalyst. Metal means platinum, palladium, nickel, like that. And another reagent is zinc and hydrochloric acid, hydrogen and phosphorus, lithium aluminum hydride. Are you getting me? Now, voice invertunda meeku?
Yes, sir.
Okay, magnesium in what?
Yes, sir.
Whenever alkyl halide is present, it is reduced by nascent hydrogen, it is converted into the alkane. For example, ethyl bromide in presence of hydrogen iodide and phosphorus, it reduces it to the ethane. And we can use zinc copper couple and also sodium in ethyl alcohol may also use it as a reducing agents. Next, see here. Alkanes can be prepared by the reduction of alkyl halides with the help of the different methods. See, reduction of alkyl halides always gives the what is a compound? That is going to be the alkane. Reduction by dissolving metal, an alkane is prepared or produced when zinc reacts with the alkyl group. See here, alkyl halide, Zn and HX. HX stands for hydrogen acid. Hydrogen acid. Zinc and HX. HX and HX అంటే ఇక్కడ HCl గా అర్థం చేసుకోండి. Okay, let us take this reaction. Alkyl halide, Zn and HCl will get zinc chloride and hydrogen. What is the mechanism in this reduction? Zinc, you know that zinc is a bivalent atom. It undergoes oxidation to give the 2 electrons. In these 2 electrons, see the alkyl halide take, see here, this electron will be alkyl halide. This alkyl and halide, 1 electron is taken by the alkyl halide, and this R group is going to be the free radical, and this free radical takes the another electron, and it is going to be the a carbanion. This carbanion now react with this hydrochloric acid, which is used here. This reacts with the hydrochloric acid, and it is taken H plus N, because R is minus, H is plus. That's why it is take hydrogen from the HCl, and it is converted into the RH, so that the chloride ion leaves, and this chloride ion take the Zn plus 2 ion. This is converted to ZnCl. You see here, it is a free radical mechanism. But you understood one thing. Whenever it is a free radical mechanism, we have the 3 steps. That is chain initiation, chain propagation, chain termination. You have learned in your, what I mean to say, in hydrocarbons. But even though it is a free radical mechanism reaction, it is not a chain reaction. Like the remaining hydrocarbons, methane chlorination, ethane chlorination, that is a chain reaction. But here, it is not a chain reaction, even though it is undergoes through the free radical mechanism, but it is not a chain reaction. Now, see here. Now, here see reduction by lithium aluminum hydride. Whenever lithium aluminum hydride, how many hydrogens are there in lithium aluminum hydride? 4 hydrogens. These hydrogens are transferred to the alkyl halides. 4 hydrogens are transferred. Therefore, 1 mole of lithium aluminum hydride can reduce 4 moles of alkyl halide. That's why with 1 mole, we'll get 4 moles of alkyl. See the mechanism here also. First of all, a hydride is transferred to the, this is alkyl halide. 1 hydrogen is transferred to here, so that the 1 molecule gets reduced to the alkane. Now here, in this byproduct, hydrogen is removed, and we will get the X to this one. So that what happened, there are 3 more hydrogens. And here now, this 3 more hydrogen and 1 more hydrogen in the next step, 1 more hydrogen is transferred to the alkane halide. So that we will get here second molecule. Similarly, the third hydrogen is transferred. You will get third molecule. The 4th hydrogen is transferred. Finally, you will get the 4th. That means here, 1 molecule of lithium aluminum hydride can produce 4 molecules of alkyl halide. That is another one is a reduction by hydrogenolysis. Hydrogenolysis is nothing but reaction with hydrogen is called hydrogenolysis. Reaction with water is called hydrolysis. Reaction with ammonia is called, anybody? Reaction with ammonia is called
Nitration.
Huh?
Nitration.
Nitration. No, what I am saying, reaction with water is called hydrolysis. Reaction with hydrogen is called hydrogenolysis. Reaction with ammonia is called
Ammonolysis.
ammonolysis. Very good. Ammonolysis. Okay. By the hydrogenolysis also, that is, alkanes can be prepared by hydrogenolysis of alkyl halide in the presence of palladium charcoal used as a catalyst. That is hydrogen over palladium charcoal, then the alkyl halide is reduced to the alkane. This is about what is called nucleophilic substitution, as well as the elimination and reduction. We will discuss in briefly about what is SN1, what is SN2 in the next class. But one more thing we are going to discuss about today, that is going to be the formation of Grignard reagent. Can anybody tell me what is Grignard reagent?
RMGX.
Alkyl magnesium halide.
Very good. Alkyl magnesium halide.
Halide.
Okay. The Grignard reagent is the general formula RMGX, where X is a halogen and R is an alkyl or aride based on the benzene ring or alkyl group. For purpose of the page, we shall take R to be an alkyl group. A typical Grignard reagent is ethyl magnesium bromide. Now,
Bromide.
how to prepare this Grignard reagent? Grignard reagents are made by adding halogenoalkane, that is alkyl halide, to the small bits of magnesium in a flask containing ethoxyethane. Commonly we call it as the diethyl ether or simply ether. The flask is fitted with a reflex condenser and the mixture is warmed over water bath of 20 to 30 minutes. మనం ఎలా ప్రిపేర్ చేస్తామంటే హాలో ఆల్కెన్స్ కి స్మాల్ బిట్స్ అంటే చిన్న చిన్న మెగ్నీషియం పీసెస్ యాడ్ చేస్తూ అరౌండ్ 20 అరౌండ్ వాటర్ బాత్ రిఫ్లెక్స్ కండెన్సర్ అంటే మీకు తెలుసు కదా, ఫిట్టింగ్ చేస్తారు. కండెన్సర్ ఫిట్ చేసి దానికి సైడ్ లో స్లోగా చిన్న చిన్న పీసెస్ యాడ్ చేసి ది గ్రిగ్నార్ రియేజెంట్ మనం ప్రిపేర్ చేస్తాం. Okay, let us see this. Ethyl magnesium bromide reacts with the magnesium in presence of ether. Everything must be perfectly dry because Grignard reagent reacts with water. ఒకవేళ డ్రైగా లేదనుకోండి, ఫామ్ అయిన గ్రిగ్నార్ రియేజెంట్ ఇమ్మీడియట్ గా దేంతో రియాక్ట్ అవుతుంది? వాటర్ తో రియాక్ట్ అవుతుంది. వాట్ హ్యాపెన్స్ వెన్ గ్రిగ్నార్ రియేజెంట్ రియాక్ట్స్ విత్ వాటర్? ఏమవుతుందండి ఒకవేళ గ్రిగ్నార్ రియేజెంట్ తో వాటర్ రియాక్ట్ అవుతే?
Alkanes form.
Very good. It forms the alkane. Very good. Let us see here. The carbon atom of organic halide which is directly attached to the halogen is, of course, electrophilic in nature. This electrophilic reactivity can be switched to nucleophilic reactivity by conversion of organomagnesium halide. That is called Grignard reagent. You know, ఇందాక నుంచి చెప్పుకున్నాం RX bond. Carbon halogen bond. Halogen is more electronegative. That's why this bond is polar bond. This bond is going to be a polar bond. It is partially negative. It is partially positive. Dry ether presence లో మనం మెగ్నీషియం తో ట్రీట్ చేస్తే then it is going to be the RMgx. R will be minus, Mg will be. మెగ్నీషియం కి రెండు ప్లేస్లు ఉంటాయి. +2 ఎప్పుడు కూడా బైవాలెంట్ ఆటమ్, bivalent cation magnesium. Okay, one is satisfied by the X minus, another is satisfied by the R minus. Chudandi, before Grignard reagent, the alkyl group is electrophilic in nature. That is, what is it? Positively charged. But after adding Grignard reagent, the alkyl group become nucleophilic. That is negatively charged. ఎందుకంటే కార్బన్ హాలోజన్ పోలిస్తే కార్బన్ is less electronegative. Whenever compared with the magnesium and carbon, magnesium is more electropositive. That's why carbon is less electropositive. అంటే ఇది నెగిటివ్. అంటే ఈ గ్రిగ్నార్ రియేజెంట్ ఫార్మేషన్ ఏమవుతుందంటే ఎలక్ట్రోఫిలిక్ నేచర్ ఆఫ్ ద కార్బన్ ఈ స్విచ్ టు ది న్యూక్లియోఫిలిక్ నేచర్. అంటే పాజిటివ్లీ చార్జ్ ఉన్న కార్బన్ డైరెక్ట్ గా నెగిటివ్ చార్జ్ లోకి వెళ్ళిపోతుంది. Now, especially note that the carbon magnesium bond in a Grignard reagent is polar covalent, with the carbon being the negative end of the type. Thus, the nucleophilicity of carbon in Grignard reagent. You also note that the magnesium halogen bond is largely ionic, as shown in the structure above. This will be the largely ionic in nature. ఎందుకు ionic nature అంటే magnesium is highly electropositive. Definitely గా carbon must have the highly electropositive nature. Okay, now let us see another slide. See, the mechanism of the formation of Grignard reagent is shown below. Like other reaction considered in this, it is also involves radical intermediate. There is one major difference, however, Grignard formation does not involve the chain mechanism. It is a non-chain radical reaction. Yes, now I see this one. See what happened? Magnesium is a dipositive ion. That means, you know, magnesium valence shell contain 2s2. That means 2 unpaired electrons. And 1 electron is taken by the halogen. And so that ఈ రెండింటి మధ్య బాండ్ ఎలా క్లీవ్ అవుతుందంటే హోమోలిటిక్ క్లీవేజా హైడ్రోలైటిక్ క్లీవేజా? RX మధ్యలో బాండ్ క్లీవేజ్ ఎట్లా అవుతుంది చెప్పండి. అక్కడ ఆరో మార్క్స్ చూస్తే హోమోలిటిక్ క్లీవేజ్ ఉందా, హైడ్రోలైటిక్ క్లీవేజ్ ఉందా?
Hydrolytic. Electrolytic.
ఇక్కడ ఇది ఏమవుతుందంటే హోమోలైటిక్ క్లీవేజ్ అంటే ఈ బాండెడ్ ఎలక్ట్రాన్స్ ఒకటేమో ఆల్కైల్ గ్రూప్ తీసుకుంటుంది, ఒకటేమో హాలోజన్. సేమ్ టైం ఈ హాలోజన్ ఏం చేస్తుందంటే ఒక ఎలక్ట్రాన్ మెగ్నీషియం నుంచి కూడా తీసుకుంటుంది. దట్స్ వై ఇట్ విల్ గెట్ ది X మైనస్. because it is a homolytic cleavage, one electron is taken by the alkyl group, will get the free radical, alkyl free radical మనకు వస్తుంది. See, this alkyl free radical now takes the free electron from the magnesium. ఒక ఎలక్ట్రాన్ ఎక్స్ కి ఇచ్చింది కదా, ఇంకొక ఎలక్ట్రాన్ మిగిలిపోయింది దీని మీద. ఆ ఎలక్ట్రాన్ ఆల్కైల్ గ్రూప్ వస్తుంది. దట్స్ వై ఇట్ ఈస్ గోయింగ్ టు బి ద బాండ్ ఫార్మేషన్. అంటే ఇందాక చెప్పాం కదా, ఇట్ ఈస్ ఏ ఫ్రీ రాడికల్ మెకానిజం, బట్ ఇట్ ఈస్ నాట్ ఏ చైన్ ఫ్రీ రాడికల్ మెకానిజం. Simply a transfer of free electron or to the alkyl group, and so the Grignard reagent is formed.
Sir,
The first step is a rate determining step. Here it is a 2 steps. One step is formation of free radical alkyl group. Second step is the formation of the Grignard. First step is RDS, rate determining step. What it means? It is a slow step. Among these 2 steps, it is a slow step. That's why it is a rate determining step. First step is a rate determining and involve the transfer of 1 electron from magnesium, which has 2 electrons in its valence shell, to the carbon halogen bond. This formation of Mg+1, which is a radical, this is then coupled with the alkyl radical form. And this like alkyl radical formed, and you will get this free Grignard reagent. See, formation of Grignard reagent must be, the condition must be dry condition. Suppose if it is not a dry condition, if it is small amount of water is there, that will react with this Grignard reagent and you will get an alkane. That's why you must remember that the dry condition is needed. For that we use the dry ether in the preparation of Grignard reagent. Now, ethers are supplies a good solvating cations because the carbon-oxygen bond is relatively polar, thus allowing the oxygen end of the ether dipole to solvate and stabilizes the magnesium. If you see this structure, you can understand. See, the magnesium is in a positive charge, dry ether oxygen by a negative charge. ఈ రెండు కూడా ఏమవుతాయంటే సాల్వేట్ అవుతాయి. That's why the Grignard reagent is more stabilized. Because of this reason, it is more stabilized. The dry ether is a good solvating agent for the Grignard reagent.
excuse me, sir.
Now, చెప్పండి.
Sir, in not this slide, sir. The formation of Grignard region, first slide. No, not this one. Yes, this one. Sir, in the alkyl halide, the halogen is more electronegative.
Yes.
It attracts the electron bond present in that bond.
Yes. What I mean
So
to say
then,
here,
how can it be homolytic, sir?
let me explain. See, magnesium, how many electrons magnesium is having?
2.
2 electrons.
2 electrons. It is highly electropositive in nature. In
Yes,
the
sir.
presence of the, what actually happens, explain చేయడానికి రావట్లేదు. యాక్చువల్లీ ఇక్కడ ఎలక్ట్రాన్ ఉంటుందా, ఈ ఎలక్ట్రాన్ ఏం చేస్తుందంటే ఈ కార్బన్ ఆల్కైల్ హాలైడ్ ఈ బాండ్ ఉంది కదా, ఈ బాండ్ కి ఒక ఎలక్ట్రాన్ షేర్ చేయబడుతుంది. అప్పుడు ఈ బాండ్ మీద ఎన్ని ఎలక్ట్రాన్స్ అవుతాయి? ఆల్రెడీ 2 electrons ఉన్నాయి. There is 1 more electron is added to here. So that
3.
what happens? It will be 3 electrons. In
Yes.
these 3 electrons, 2 electron is taken by the X and 1 electron is taken by the alkyl. That's why what happens, alkyl, this alkyl group converted into the free radical, and here 1 electron is transferred to the here this alkyl halide bond. Therefore, what happens? 1 more electron is free on the magnesium. Therefore, now this is going to be the, what happens? It is also a free radical. Now this free radical and this free radical combine and you will get a Grignard. Followed my point? See, in this slide I told you. In first is the rate determining step and involve the transfer of 1 electron from magnesium to the carbon halogen bond. That's why it is looks like a homolytic cleavage. 1 electron is taken by the halogen from this bond, 1 electron from the magnesium it is taken, and it becomes the X minus. This is the one. Are you cleared your doubt?
Yes, sir. Thank you.
Okay. Now here, dry ether low, the Grignard reagent is more stabilized. The reason is the Grignard reagent is get solvated by the, what is this? Dry ether. In the diethyl ether or simply ether, the oxygen is having negative charge, and this negatively charged one stabilizes the magnesium positively charged. So that in this way, the Grignard reagent is solvated by the dry ether. That's why ethers are good stabilizing agent for the what is that Grignard reagent. Ethers are surprisingly good at solvating cations because the carbon-oxygen bond is relatively polar, thus allowing the oxygen end of the ether dipole to solvate and stabilizes the magnesium ion. Now see here. See, sometimes you get a question on the reactivity of the Grignard reagent or ease of formation of Grignard. Suppose there are alkyl iodide, alkyl bromide, alkyl chloride is there. These three are is there. Whenever these are three treated with the magnesium, you remember that alkyl iodide readily form Grignard reagent when compared to the alkyl bromides, and it is readily formed compared to the alkyl chloride, like this.
Yes, sir.
Iodides, bromides, and gold. This is the relative formation of Grignard reagent of the alkyl. Suppose if it is alkyl groups are there, methyl, ethyl, same halogen. అయోడిన్ కానీ బ్రోమిన్ కానీ క్లోరిన్ కానీ ఏదో ఒక హాలోజన్ ఉందనుకోండి, అప్పుడు ఏమవుతుందంటే with the increasing the bulky nature in the alkyl group, the reactivity decreases in the formation of the Grignard. Methyl halides readily form Grignard reagent when compared to the ethyl halides, and it is readily formed when compared to the propyl iodides and so on, butyl, pentyl, and so on. Okay, this is two things you must remember. Now, what is the nature of the Grignard reagent? The Grignard reagent acts as a base, and also Grignard reagent behaves as a nucleus. Let us take the base. How it is acts as a base? It is readily reactive with compounds having the active hydrogens. Active hydrogens are nothing but which readily supply hydrogen ఏదైతే ఈజీగా సప్లై చేస్తుందో రియాక్షన్ లో వాటిని ఏమంటామంటే యాక్టివ్ హైడ్రోజన్ కాంపౌండ్. Whenever a Grignard reagent is treated with the either alcohols or amines or this is going to be the alcohols. This is another. See, whenever you see this one, whenever it is treated with this H2O like this, whenever it is treated with the compounds which contain active hydrogen, they are get reduced. Because in this reaction, the Grignard reagent acts as a base and it absorbs the proton from these compounds like from alcohols and water, alcohols, amines, what not easy hydrogen absorption, H plus ion. That's why in this way, in this reaction, it acts as a base. Now, it is acts as a nucleophile. How it acts as a nucleophile? Whenever you have learned in carbonyl compounds, అయిపోయిందా మీకు? దయానంద్ సార్ చెప్పారు కదా, అయిందా అండి? ఎనీబడి?
లేదు సార్.
ఇంకొక క్లాస్ అయిపోయింది.
Okay. Carbonyl compounds లో Grignard reagent, how does it react with the aldehydes and ketones and ఒక టాపిక్ ఉంటుంది. That is a very important topic. Here it is undergoing, that is aldehyde. This is going to be the aldehyde. The Grignard reagent attacks on the that is carbonyl compounds, so that in this reaction, the ఇక్కడ కార్బన్ చూసారా, ఇది న్యూక్లియోఫిలిక్ సెంటర్. ఎందుకు న్యూక్లియోఫిలిక్ సెంటర్ అండి? Carbon oxygen లో oxygen is more electronegative. Therefore, the pi bond is shifted to the oxygen. Therefore, carbon get the positive charge. RMGX లో R will be the minus. ఇందాక చెప్పుకున్నాం R కి minus charge. That's why it is readily attacks on the carbon. And this R is a nucleophile and attacks on the nucleophilic center, so that it gives the R. In this reaction, reaction of the Grignard reagent with the carbonyl compounds, it acts as a nucleophile. Reaction of the Grignard reagent with compounds having active hydrogen, it acts as a base. These are the two things. Okay, we will stop our discussion here. And there is one more class for the alkyl halides required, and there we'll discuss more about what is how to prepare alkyl halides and what is SN1 and SN2. And most of the cases you will get the question on SN1 and SN2. There we are going to discuss. Okay.
Okay, sir. Thank you, sir.
We'll stop our All of you
Thank-
writing exams? All of you writing exams or test?
Yes, sir.
ఈ పేర్లు ఇక్కడ కనిపించినట్లేదు నాకు, చూస్తున్నాను. రాస్తున్నారా మీరు ఎగ్జామ్? మన కెమికల్ బాండ్ రాసారా? కెమికల్
Yes.
బాండ్ రాస్తారా?
No, sir.
Lead, sir.
మనీషా నువ్వు రాసావా?
No, sir.
సోనియా? సోనియా? రంజిత్? రంజిత్? బీవీ ఎవరు?
సార్ నేను భవానీ.
భవానీ. నీ పేరు రీటైమ్ చేసుకో, భవానీ అని. నువ్వు రాసావా ఎగ్జామ్? కూడా కనిపించట్లేదు.
ఎస్ సార్.
రాసావా రాయలేదా?
రాశాను సార్.
ఎన్ని మార్క్స్ వచ్చాయి?
17 సార్.
ఓకే. అయితే మోర్ ఏంటంటే మీకు ఒక ఇంపార్టెంట్ థింగ్ ఏంటంటే ఎగ్జామ్స్ రాస్తేనే మీకు బిట్స్ ప్రాక్టీస్ అవుతాయి. ఎగ్జామ్స్ మీరు ఎన్ని రాస్తారో, ఎంత పర్ఫార్మెన్స్ చూపెడతారో ఆ టెస్టులతోటే మీకు దాని మీద ఒక గ్రిప్ వస్తుంది. అదర్వైజ్ యు ఆర్ అనేబుల్ టు వాట్ ఐ మీన్ టు సే హ్యాండిల్ ది క్వశ్చన్స్. మీరు ఎన్ని టెస్టులు రాస్తారో నేను మీకు ఒక హింట్ చెప్తాను. ఈ టెస్ట్ల మీద, మేము పెట్టిన టెస్ట్ల మీద ఎవరికైతే గుడ్ మార్క్స్ వచ్చినాయో దే గాట్ గుడ్ స్కోర్ ఇన్ ఈవెన్ ఇన్ ద ఫైనల్ ఎగ్జామ్ ఆల్సో. అందుకని మీరు ఏం చేయండి అంటే టెస్ట్ రాయడానికి ప్రయత్నం చేయండి. మీకు రాకపోతే మేము ఎట్లా కీ పెడుతున్నాను, టెస్ట్ చేసుకోండి. ఏమైనా డౌట్స్ ఉంటే అడగండి. వీఆర్ ప్లాన్ ఫర్ ఏ 20 టెస్ట్, ఆల్మోస్ట్ 20 టెస్ట్ల దాకా పెడతాము. 2 గ్రాండ్ టెస్ట్లు కూడా పెడతాము. మీరు టెస్ట్లు అటెండ్ కావాలి, అందులో ఉన్న ఆన్సర్స్ తెలుసుకోవాలి. తర్వాత ఒకవేళ మీరు అర్థం కాకపోయినా, ఏదైనా క్వశ్చన్ అర్థం కాకపోయినా మళ్ళీ మాకు టెస్ట్ చేసినా మేము వాటికి సంబంధించిన సొల్యూషన్ కూడా చెప్తాం. మీరు అట్లా ప్రాక్టీస్ చేస్తేనే, టెస్ట్ ప్రాక్టీస్ చేస్తేనే మీకు గుడ్ స్కోరింగ్ ఉంటుంది. ఊరికే క్లాస్ వినడం వల్ల కూడా అంత 50% లాభం ఉంటుంది. మీరు టెస్ట్ కూడా ప్రాక్టీస్ చేయాలి. కంపల్సరీ టెస్ట్ రాయడానికి ప్రయత్నం చేయండి. సరేనా?
ఓకే సార్.